The James Webb Space Telescope, JWST, is a top-notch international tool for space study. It aims to figure out our solar system, planets around other stars, and how the universe is put together, all to learn why we're here. Recently, researchers aimed the JWST at a star about 120 light-years away. They saw convincing signs of carbon stuff in the air of a planet that might have huge oceans. It's a cool find for scientists. So how did they figure this out? This shows us a planet way different from ours and makes us wonder if other planets out there could support life. Let's check out this exoplanet finding and the interesting details it shows. If you want to keep up with the latest space news, hit that follow button, like the video, share it, and turn on notifications. NASA's James Webb Space Telescope just dropped a mind-blowing discovery about the exoplanet K2-18b, a weird world that's about 8.6 times bigger than Earth. What's super exciting is they spotted carbon gases like methane and carbon dioxide in its air. This backs up earlier studies that said K2-18b might be good for life with a hydrogen-filled sky and maybe a water surface. NASA's Hubble Space Telescope first checked out this planet's air in a livable zone, teaching us a lot about this star system. K2-18b is around 120 light-years away in the Leo constellation, circling a cool dwarf star called K2-18. It's in the star's habitable zone and is a type of planet between Earth and Neptune in size, called subneptunes. We don't have any planets like that in our solar system. The idea that K2-18b has carbon stuff and lots of hydrogen gets astronomers excited. Many think these planets are the best place to look for life. The methane and carbon dioxide, and especially the lack of ammonia, make the idea stronger that this world might have an ocean under its hydrogen skies. Initial looks even hint at dimethyl sulfide, a molecule linked to life on Earth that's mostly made by tiny sea bugs. But finding it on K2-18b is still just a guess and needs more checking. The JWST is still collecting data to confirm if there's enough dimethyl sulfide in this exoplanet's air. According to a scientist at the University of Cambridge, just because K2-18b is in a spot where water could exist and has carbon gases doesn't mean it has life, especially since it's 2.6 times bigger than Earth. It's likely covered in a thick, icy shell with a thinner hydrogen air layer and maybe surface oceans. Even if there's water, it might be too extreme to support life as we know it because of pressure or weird chemicals. Though researchers now have the best air data ever from a habitable subneptune, letting them pick out different stuff in the air. A Cardiff University scientist said they got past viewing problems by watching how starlight went through the exoplanet's air as it passed by. K2-18b dims the brightness of its star when it crosses in front, which is how NASA's K2 mission first found it. During these passes, some starlight goes through the planet's air before hitting Earth. Space telescopes like JWST can then study the light to figure out what chemicals are in the air. The team plans to do yet more tests using JWST to check for specific molecules and learn about K2-18b's weather. Their big plan is to look for signs of life on planets that could support life, which could totally change how we see life in the universe. Also, JWST helped with other cool finds. Astronomers using it saw complex soot-like molecules in a galaxy far, far away, the earliest we've ever seen them. It's both awesome and a bit creepy. These findings change our understanding of the universe. The molecules found, aromatic hydrocarbons, were seen in a galaxy formed when the universe was about 10% of its current age. These carbon-rich compounds, found on Earth in stuff like oil and coal which contribute to air pollution, are big and made of dozens or hundreds of atoms. What's amazing is that these molecules showed up fairly soon after the Big Bang against what we thought. The light we saw is from about 1.5 billion years after the Big Bang. The universe is now about 13.8 billion years old, so that's super early. JWST aided with finding this evidence and will help us seek similar evidence, potentially going back a billion years in the past. If we could see far back in time, could we spot more of these molecules closer to the start of the universe? Our fundamental queries on cosmic evolution will be required. Before, astronomers guessed these compounds were in the early universe. Now, JWST's sharp view lets us see where they are. The uneven spread of these compounds in the distant galaxy SP41847 adds to the mystery. This galaxy had already grown to a mass similar to the Milky Way and made similar amounts of carbon and oxygen. As we explore the unknown, led by curiosity, we're humbled by the vastness of space. Each discovery gets us closer to solving the universe's puzzles. As we get better at space discovery, it's just a matter of time before we find more secrets, revealing truths about our spot in it all. The James Webb Space Telescope keeps making game-changing discoveries, which is expanding our astronomical awareness. JWST's views change how we understand exoplanets and space structures and push our scientific limits. This tool lets us see deeper into space than ever, spotting stuff that past researchers missed. Finding organic compounds in old galaxies confirms JWST's part in helping us understand the early universe and its growth. The implication that life, or the parts for it, may be more common than we thought is one of the most exciting things about these results. The presence of carbon stuff on planets like K2-18b offers new ways to explore signs of life on possible Earth-like worlds. These substances, which include methane and carbon dioxide, are connected to biological activity on our planet. While finding them on other worlds doesn't confirm alien life, it certainly inspires scientists to find more. NASA missions will focus more on that possibilities. The JWST's precision in breaking down planetary airs is a step forward. It lets researchers spot basic stuff and pick out more complex chemical hints that could point to life. This detail is key for checking if remote planets can truly support living things. As our insights get sharper, so does our ability to spot subtle signs of life. JWST is handing out critical data on how galaxies are born and grow. By looking at galaxies from the early universe, astronomers can map how stars form, what elements they're made of, and how gravity affects star systems over billions of years. This info helps us piece together the story of our own Milky Way. Finding aromatic hydrocarbons in an old galaxy highlights how far we've come in understanding where space structures come from. As we reach farther into space, every insight helps us consider our critical human questions. Do we share the universe? How did existence kick off? What will happen to the cosmos? Dreamers have pondered these questions for centuries. Now, with tools like the James Webb Space Telescope, we can find the answers. Every fresh discovery widens our view and brings us nearer to decoding the truths hidden among the stars. Astronomers are excited that K2-18b has carbon and a hydrogen vibe, and many think planets like this are the best places to look for alien life. The methane and carbon dioxide hints, and especially the lack of ammonia, suggest a possible ocean under those hydrogen skies. Some initial peaks even pointed to dimethyl sulfide, a molecule linked to life on Earth and mostly made by tiny sea creatures. Still, we need more info before we claim anything definite. JWST is grabbing more data to confirm if there's enough dimethyl sulfide up there. One expert from Cambridge said that even if K2-18b has water and carbon, that does not mean it has life, especially since the planet is way bigger than Earth. It's probably covered in thick, icy stuff with a thin hydrogen atmosphere, maybe with oceans. If it does have water, it might be too crazy, like super pressurized or unstable, for life as we see it. But hey, researchers now have the best atmospheric data we have ever gotten from a habitable subneptune, so they can tell what's in the air. A scientist from Cardiff University said they figured out how to study the starlight as it passed through the planet's air. K2-18b is a transiting exoplanet, which means it dims its star when it passes in front of it. That's how NASA's K2 mission noticed it. During these passes, some starlight goes through the planet's atmosphere before reaching us. Space telescopes can then check out the light for clues about what's in the air. The team is planning more tests with JWST to see if they can spot specific molecules and learn about the planet's weather. Basically, they want to find biosignatures on planets that could have life, which could totally change how we think about life in the universe. Also, JWST helped spot some complex organic molecules in a far-off galaxy. It's the earliest we've ever found these compounds. These finds are shifting how we understand the universe. These molecules like smog or soot were spotted in a galaxy that formed when the universe was only 10% of its current age. These carbon-rich compounds, found in things like oil and coal on Earth, contribute to air pollution. They are huge and chemically complicated, made of tons of atoms. It's amazing that these molecules showed up so soon after the Big Bang, which goes against what people used to think. The light we saw from that galaxy started its trip about 1.5 billion years after the Big Bang. The universe is about 13.8 billion years old now, so that's super early. JWST made it possible, and it could help us find even older evidence. What if we could see even further back and find more of these molecules closer to the beginning? It makes us think hard about how the cosmos might have changed. Before, astronomers could only guess that these compounds were there, but now JWST's killer resolution lets us see where they are. Plus, these compounds are not spread evenly, which adds to the mystery. This galaxy was already as big as the Milky Way and had a similar amount of carbon and oxygen, even when the universe was still a baby. As we go out there and explore, we keep getting surprised by how big and complicated everything is. Every find gets us closer to solving the puzzles of the universe. As our space skills get better, it's only a matter of time before we learn even more secrets and understand our place in everything. As we learn more about space, the James Webb Space Telescope keeps dropping awesome discoveries. Its peaks are changing how we see planets and galaxies, pushing our science to new limits. This tool lets us look farther than ever, finding stuff that other researchers missed. The find of old organic compounds in ancient galaxies shows how much JWST helps us figure out the early universe and how it evolved. One of the best parts of these results is the idea that life, or at least the stuff for it, might be more common than we thought. The carbon stuff on planets like K2-18b opens new paths to look for signs of life on similar worlds. These things, like methane and carbon dioxide, are tied to biological activity on Earth. Even if they don't prove alien life, they push scientists to dig deeper. NASA has more missions coming up that will focus on this stuff. JWST's ability to break down planetary atmospheres is a big step up. It lets researchers spot basic elements and find more complex chemical hints of life. This kind of detail is key to knowing if planets can really support organisms. As our view gets clearer, we get better at spotting signs of life like gases, organic molecules, or other signs of biological stuff. Besides exoplanets, JWST is giving us data on how galaxies are born and how they grow. By looking at old galaxies, astronomers can chart how stars form, what elements are in them, and how gravity affects stellar systems over billions of years. This info is key to putting together the story of our own Milky Way. The aromatic hydrocarbons in a galaxy from the early universe show how far we've come in understanding where cosmic structures come from. As we reach farther into space, every new thing we learn brings us closer to answering some big human questions. Are we alone? How did life start? How will the cosmos end? These questions have been on the minds of scientists, thinkers, and dreamers for ages. Now, with tools like the James Webb Space Telescope, we're more ready than ever to find some answers. Each new find makes our view bigger and pulls us closer to knowing the truths hidden in the stars.